Okay, so today we are going into module 2.4, writing equivalent logarithmic expressions. It's going to be really good practice for you to do the practice problems on the top of the page, and we will do more practice in class, of course. So now that you know the properties of logarithms, which we did last time, and that you should have down pretty well by now, you can use those properties to write log expressions that are equivalent to make our calculations simpler. So let's start with number one. So number one, we've got an expanded equation, right? We've got log base 2, x plus 2, plus log base 2, same base again, 3 equals log 2 of 27. So we've got same bases going on. That helps us a lot when things are the same base. So now we can condense that back down. And so since we have addition here, that's going to tell us that we're multiplying. So we would have log 2 of x plus 2 times 3 equals the log 2 of 27. Once we have the same bases, remember our rule, once we have the same bases that are equivalent to one another, we know that these amounts must be equivalent to one another. Okay? So the way we can solve that is now we can just do 3 times x plus 2 equals 27. So we're going to divide both sides by 3 first, and we're going to get x plus 2 equals 9, so our x equals 7. We went back and plugged that in over here. 7 plus 2 is 9. 9 times 3 is 27. So they would be equivalent equations. We're not finding the log, remember. We're just finding what x is equivalent to. Okay, so log 2 of 14. What do you think you need to solve this equation? If I asked you to expand that out, how could you expand it? Something would be useful for us. So we could expand that by using log 2 plus, if we're using multiplication, 2 times 7 is 14. So log 7 would work. So the only thing I would need, what's log 2? Anytime the base and the answer are the same. Anytime the base and the answer are the same, we know that that equals 1. So really all we would need to find is a value for log 7, which you're going to learn how to do fairly soon. For now, you're just going to leave it like that. Okay? So next one would be similar to that. So what could you break 20 into if I was asking you to find log 420? Then you need to ask yourself, what could I break 20 into that might use 4 as one of my factors? So that would be log 4, which we know has a value of 1. Good. So log 4, 5. So your answer would be 1 plus log 4, 5. We could estimate this answer right here, but we'll find it exactly, pretty close to exactly in a minute. Okay, so now we've got an equation set up in number 4, right? So we have logs on this side, but we've got a number on this side. So this is where your ability to convert between exponential form and logarithmic form really comes in handy. Okay, because I know using my circular motion that my base raised to the power gives me this answer. So let's rewrite this in exponential form. So 3 to the 0 power equals x plus 5. Anything to the 0 power is 1. So 1 equals x plus 5. Then I would just need to subtract 5 from both sides. So x equals negative 4. Okay? Good. Okay, so let's go down to the bottom of the first page of your notes, and we're going to do some review on same base. Same base really helps us when we're trying to solve these equations. So remember, same base means exactly that. You're trying to get these bases of your exponents to be the same thing. Currently, they're not, but they are. For example, if you look at 81, 3 is a factor of 81. I can find 3 to some power that gives me 81. Once your bases are the same, then you can ignore the bases and just set the exponents equal to each other and solve. So 3 is a base, so 3 to the 2n plus 1. And I'm going to try if some base 3 to some power will give me 81. Well, 3 to the second power is 9, 3 to the third power is 27, 3 to the fourth is 81. Once I have those equivalent, that and that, now I can set them equal to each other and solve. So 2n would equal 3, and then n equals 3 halves. Okay. Number 2. In this case, 4 is not a base of 8. 4 to the first is 4. 4 squared is 16, which is not 8. So I'm actually going to have to change both of these to a base that I can use. And they both have a common base of 2. So 4 is the equivalent of 2 squared, which I'm going to raise to the 2x. And then 8 is the equivalent of 2 to the third, which I'm then going to raise to x to the x minus 1. I know that when I raise a power to a power, of course, I multiply those exponents together. I multiply these exponents together. So in order to solve my equation, I'm going to do 2 times 2x equals 3 times x minus 1. So 4x equals 3x minus 3. I'm going to subtract 3x from both sides. So I'll get x equals negative 3. Okay. Go ahead and do number 3 and 4 on your own, and then come back, hit pause, and then come back and check your work. Okay, let's change both of these. Number 3, we need to change those bases down to something that's usable. Let's see if 256 is a base of 4. So 4 squared is 16. 4 to the third is 64. 4 to the fourth, I'd be multiplying by another 4. So 60 times 4 is 240, plus another 16 would be 256. So it looks like that is 4 to the fourth power. Because that is a fraction, I know that it's 4 to the negative fourth. That's going to be a negative exponent. On this side, I have 4 to the 3p is greater than. Now my bases are the same. I can now ignore them for the sake of solving. Divide by 3. So p is greater than negative 4 thirds. Lastly, number 4. I do know that 16 is a base of 2. So I have 2 to the 2n on this side is less than or equal to 2 to the third is 8. So 2 to the fourth equals 16. Again, because that's a 1 over 16, I know that's going to be a negative exponent. So it's going to be 2 to the negative fourth. My bases are the same. I can just use my exponents and set them equal to each other, which is negative 4. So m would be less than or equal to negative 2. Let's clean that up a little bit. Negative 2. Okay, good. So there's our whole first page notes. Take a look back over that, make sure everything makes sense to you. And we will move on to page 2. Okay, so now that we've got logarithmic equations set up and we know how to manipulate them a little bit, now we can actually just go through and solve. And remember, you're not solving for the value of the exponent, you're solving for the value of the variable that's missing. So in the first problem, you're going to be solving for v. In the second problem, you're going to be solving for x. Third problem, you're going to be solving for x. Fourth problem, you're going to be solving for x. You're solving for something specific, but now you're using the properties and rules of logarithms to help you get there. Okay, so in number 1, do I have the same logarithm on both sides with the same base? Yes, I do. I have log 4 and log 4. And I know that whatever their answer is has to be equal to one another. So once your bases are the same, once I've established that that log 4 is the same, I can ignore them. And I can just set those parentheses equal to each other. Okay? So I'm going to add 4v over here, and I'm going to subtract 8 over here. So I'll get 5v equals negative 10, so my v equals negative 2. Okay? Look at number 1 and 2. What do you see different between number 1 and number 2? Okay? This side of the equation, oh, we've got an expansion going on in here, and since that's subtraction, we know that we need to condense that back down using division. But on the right-hand side, I don't have any log base, right? I've just got a number there. So remember that because that's it's going to be in logarithmic form, we're going to use that circular motion of 3 log, our base raised to this power gives us our answer. So just remember that for a minute. So let's condense this back down. We do that by division. So you have log 3 x over x minus 1. You just write them. The first one is your numerator, second one is your denominator, equals 2. Okay. Now using that circular motion that we've talked about a lot, you go from your base to raising to the exponent gives you your answer. So 3 squared equals x times x minus 1. I'm sorry, x over x minus 1. That'll work better. Let's get that out of there. X over x minus 1. Okay? Then if I'm going to solve for that, I'm going to multiply. 3 squared is 9. And I need to multiply both sides by this x minus 1. So that it will cancel itself out. So that's going to cancel. So I'll get 9 times x minus 1 equals x. I get 9x minus 9 equals x. I'm going to move that 9x to the other side. So I get negative 9 equals negative 8x. So x equals 9/8. That's for number 2. Number 3, you have room to write it there. I'm going to go ahead and do it on a blank sheet on the screen so that I'm not pressed for space. Okay, so this is number 3. And we have log 9 3x plus log 9 2 equals 2. Okay, so since I have an addition in here, I know that that's going to be condensed by multiplication. So I'm going to multiply 3x times 2. So that will give me log of 9. 3x times 2 is 6x equals 2. Now I'm going to use my logarithmic function again. 9 to the second power will give us 6x. So 9 squared equals 6x. 81 equals 6x. Dividing both sides by 6 and reducing, that would be 27 over 2. Putting 3 into 81, 3 into 6. Okay. And lastly, while I'm here, we'll just go ahead and do number 4, which is log 2 x plus 7 equals 0. Remember, now that I don't have a log on the right-hand side, I can just go straight to the step where I am raising 2 to the 0 power equals x plus 7. So 2 to the 0 power equals x plus 7. Anything to the 0 power is 1. Subtracting 7. So x equals negative 6. Okay. Put a star next to anything you have a question on, and we definitely will come back to it. Okay, going down to the bottom of page 2 for your notes. And we're going to solve for given values. Remember back on page 1, let's go back, and I said over here, it would be really helpful if we had a value for log of 2/7. And there actually is a value for that. Let me give you what that value is. I haven't taught you the trick yet, but it's coming. So there's an actual value for log 2.7, and that value is approximately 2.8074, which means if I raise 2 to the 2.8074, I'll get approximately 7. When I do raise that 2 to the 2.8074, I get 7.000219. That's pretty close to 7. Close enough for me, right? It's helping you approximate the value of that logarithm. Okay, so when we're going back to page 3, and it's saying, now they're giving you approximate values. So they're saying, okay, use log 2.3 equals approximately 1.5850. What does that mean? 2 raised to the 1.5850 power gives you approximately 3. That's what that means, okay? Still using our circular motion, 2 to this gives us this. Still means the same thing. So now that we have something usable for what we didn't have a value for before, now we can approximate logs. So it says approximate the log value of 248. So since we have a log 3, let's expand this using our logs. So let's figure out what we can split 48 down into. And since we already have a 3, let's use the 3. So 3 times 16 gives us 48. So if I expand that out, I would have log 2.3, which I have a value for, and I'm expanding by addition since we're doing multiplication, and log 2 of 16. Both of these values, both of these logs have actual values. Okay, so they're telling us this approximate value is 1.5850. And then tell me what the value of log 216 is. That value is 4. 2 to the 4th power gives us 16. So now I can approximate that my value of log 248 is about add those together. And it's going to be about 5.5850. You're just approximating. This little squiggly equal signs means approximately, almost equal to, but not equal. Okay, close to, but not equal. And that would be your answer right there. Okay, so let's do some practice with those. On number 2, they're giving you values. Okay. On number 2A, actually, I'd like you to use your your power property. Okay, so since they're giving you a log of 5.2, how can you rewrite 8 as a base of 2? You would do log 5 to the 3rd. And I know from power property that power is going to shoot out to the front. So that's going to equal 3 times the log of 5.2. And they're telling me that is, the value of that is 0.4307. Okay. So that would be, 3 times that would be 21, 9, and 12. So 1.2921 is approximately log 5, 8 is approximately 1.2921. And if you check that with your calculator, it's kind of, wouldn't say fun, it's kind of good to go back and check your work and see is that really right. So 5 to the 1.2921 power. In fact, I'll do it on the calculator here so you can see. Let's find it. 5 to the 1.2921 power gives you 8.0009. It's pretty close to 8. We can call that 8. Okay. All right, once you go ahead and try B, C, and D on your own, and then come back and check your answers. Hit pause, figure them out, come back and check. Okay, B. This is a quotient. I've got a fraction going on that tells me division. So the way I expand that is going to be log of 5.3 minus the log of 5.2 I have values for both of those. I have 0.6826 minus 0.4307. So your answer should be about, that would be 19, 5, and 2, 0.2519. And you can check that again. That means if I raise it to that power, I should get 3/2 or 1.5. So 5 to the 5, no, I forgot what it was. Go back, 2519. To the 0.2519, 1.4999, that rounds off to 1.5. So that's a legit answer, okay? All right. Log of 530. Well, must be the only thing I can break 30 down into would be log 5 times 6. And then I guess I could break that 6 down into a 3 and a 2. So let's see what I can do with that. I can do the log of 5 plus the log of 5 plus the log of 5 2. Well, log of 5 is easy because I know that's 1. And then my value for log 5 is 0.6826. And my log 5 value is 0.4307. So all I have to do is add those up, and you should get 1, 2, 2.1133. 2.1133. Let's plug that back in and see if we get close to 30. If we raise 5 to the 2.1133, see what we get. So 5 to the 2.1133, and we get 30. Okay, you're approximating the value of these logs. You're coming pretty close. Rounding off, you get really close. Okay. All right. So again, because we've got division going on here, we know that we're going to use, or sorry, because you have a fraction going on here, you know you're going to use division. So you're going to have log 510 minus log 59. It's sort of helpful. Not really. Let's expand that a little bit. So we have log 5. This gives me 2 times 5 minus log 5 3 times 3. Now you've kind of got an expansion within an expansion. So now we need to look at these each individually and expand them out. Okay? So we're going to do log 2, log 5 plus log 5 minus, and actually couldn't we write this as an exponent? That would actually be the same as 3 squared, which is 2 log 5. You have to be really careful because what you're doing is you're subtracting that whole log. So you'd have to be sure you flipped both of those signs. Okay? So now my log 5 value is 0.4307. My log 5 value is 1 minus 2 times my log 5 value is 0.6826. 0.6826. So we've got 1.4307 minus 0.68. Come back. $1.3652. 1.3652. Is that what I said? Yes. And we had over here 1.4307. 1.4307 minus 1.3652. So we should have an approximate value of 0.0655. 1.0655. So again, let's take that, and we're trying to see if we can get log 10 ninths. So that's about 9.111, somewhere in there. Okay, if we did 10 divided by 9, all right, it's 1.1 indefinite. And so if we raised 5 y to the x, we would come up with 0.0655, 0.055, 1.11175, and then because of rounding, but it's still pretty close in here. Okay. We will definitely do more practice with this in class, but that should do it for your notes for 2.4. If you have any questions, bring them to class, please. Okay, that's it. Thanks.